Okay, no, I could, but sum and difference formulas. Remember we did this on Friday and Thursday last week? So sum and difference formulas are ones that you should really know and memorize. If you have a highlighter, today what we're going to look at are double angle formulas, and we're also going to look at half angle formulas. So these two are the ones that we're going to highlight. Recording for 8th hour in case they have never been. Do you want to say something to 8th hour? Okay, Elizabeth says that second hour is so much better and that they got cookies today. Sarah, do you want to say something?
I have nothing to say.
Larissa, maybe you should stay awake. Actually, you're gone at track, so that doesn't matter. Tara Westland should stay awake. How about that? Okay. All right. So, 8th hour, I hope you're having a good day. What a better way to end our day than to look at double angle formulas and half angle formulas. So, we try the notes, and we'll fill them out. I do? This is the first, and this is the most important of the double angle formulas. Sine of 2a, so double of an angle, is equal to 2 times the sine of a times the cosine of a. You do use this in calculus quite often. So we could verify this through the previous identities that we've talked about. So for example, I'll just do a quick one, okay? Just very quick. I could rewrite sine of 2a as sine of a plus a, correct? Now we could use our sum formula, which is sine of a cosine of a plus cosine of a sine of a. You guys agree that that's equal to 2 sine of a cosine of a? So we could use really all the different relationships that we've looked at before in order to verify new identities. And there's just an endless number of identities that we can end up coming up with. So these are, we're not going to show every single one. That's just one example. Cosine has actually 3 of them. And so the cosine of 2a, the first one is cosine squared of a minus sine squared of a. Then we have 2 cosine squared of a minus 1, or 1 minus 2 sine squared of a. So you really have 3 options that you can choose to use. And then tangent of 2a is equal to, I don't ever remember this one, 2 tangent of a, because you never use it, divided by 1 minus tangent squared of a. And that's what we got. Those are double angles. Okay? Any questions? What's a double angle? That's a good question. So for example, let's say you had sine of 60 degrees. That's the same as sine of 2 times 30 degrees. Right? Yeah, it allows us to separate it. Now, why is that helpful? Double angles aren't always the most helpful to be able to utilize. The formulas are. Double angles do come up from time to time later on. Half angles are easier. So kind of like how you have a double angle there, we can also do like sine of a over 2. Well, that's more interesting. Like the sine of, say, 15 degrees would be equal to the sine of 30 over 2. And so then we can use, we know the sine of 30, so we can make use of that. We know the sine of 60 and the sine of 30, so that's not really all that interesting. But the double angle relationship comes up very often in calculus. So why are we covering this now? These are formulas that you will encounter in calculus. Okay? That's really the main reason why we're covering it. So the first example is not real easy. Okay? We're going to do our best. It says given cosecant of x is equal to 2, and x is in the second quadrant, find sine of 2x, cosine of 2x, and tangent of 2x. Okay? So, are you ready? Are you sure? Okay. All right. Well, if cosecant of x is equal to 2, then I know sine of x is equal to what? 1/2. Now, it says I'd like to find sine of 2x. Well, I know this formula. Sine of 2x is equal to 2 times the sine of x times the cosine of x. It says that I need to find sine of x and cosine of x in order to evaluate what sine of 2x is. Do you know what sine of x is? 1/2. Do we know yet what cosine of x is? How could I figure that out? Without inversing, what could we do? Oh, so you want it? We can't actually algebraically solve in this situation. We'll see. We'll see if we can. See if we can get this. Okay. We're in the second quadrant. Okay. So positive for sine. Negative for sine. Cosine is positive here, negative here, negative here. Okay. If we are in the second quadrant, is cosine going to be positive or negative? It's going to be negative. Okay? And there's a way that we can relate the values of sine and cosine together. Namely this. Sine squared of x plus cosine squared of x is equal to 1. Did this come up on your ACT on Saturday? Not everybody had the same test, by the way, so no. So, but this is an important one to know. So if I take 1/2 and I square it, what do I get? 1/4. So 1/4 plus cosine squared of x is equal to 1. What do I do to both sides? So I get cosine squared of x is equal to 3/4. Square root of 3 over 2, is it positive or negative? It's negative because I'm working in the second quadrant. So we have cosine of x is equal to negative square root of 3 over 2. Good. Now do I have enough information to come up with sine of 2x? Yeah. That'll be equal to 2 times 1/2 times negative square root of 3 over 2, which is negative square root of 3 over 2. Okay, it says that x is in the second quadrant. My angle is in the second quadrant. So therefore, cosine is positive in the first, negative in the second, negative in the third, positive in the fourth. So when we solve down here, we got cosine squared of x is equal to 3/4, and we square root of both sides. We get plus or minus the square root of 3/2. You got to know which one to use, the positive or the negative. We choose the negative because cosine is negative in the second quadrant. Is that good? So there I have it. Now we move on to the cosine of the double angle. So cosine of 2x is equal to, and you have three formulas to choose from. Which one would you like to choose? Let's use cosine squared minus sine squared. Do you guys or you want to use the which one? You want to use the bottom one? The 1 minus 2 sine squared of a? Okay. So we'll go 1 minus 2, nope, sine squared of a. They're all the same. So that means I have to square the sine of a. What's the sine of a squared? 1/4. So I have 1 minus 2 times 1/4. What's 2 times a fourth? A half. So 1 minus a half is 1/2. So we have, I'm sorry I didn't leave a whole lot of room for you guys here. We have sine of 2x is negative square root 3/2. We have the cosine of 2x is 1/2. Now I've got one more. Tangent. Tangent of 2x is equal to 2 tangent over 1 minus tangent squared. If sine of x is 1/2 and cosine of x is negative square root of 3/2, how do you find tangent? Right, tangent, you would take sine divided by cosine, right? So tangent of x is equal to, we take 1/2 and divide it by the square root of 3/2, negative. Right? Sine divided by cosine. So if we multiply it by 2 over the square root of 3, negative, you get negative 1 over the square root of 3, which is negative square root of 3/3. Got it? Twos cancel. 1 over negative square root of 3. Can I just show you guys a shortcut? Okay. Yes. Right here. Cosecant is 2, so sine is 1/2. So I'll show you guys a hint. Now that you know tangent is equal to negative square root of 3/3, you can plug it into this formula, correct? Well, I'll give you a little hint here. If you know sine of the double angle and you know cosine of the double angle, you can simply divide those. So I'll show you. So I just want you guys to know though that this is a formula you can use, but I'll show you a shortcut that they don't bring up in this situation. So you can use that, but you could also use this. Sine of 2x over cosine of 2x is equal to tangent. Whoop. So sine of 2x over cosine of 2x is equal to tangent of 2x. So what's sine of 2x? Sine of 2x is negative square root of 3/2. Divided by or multiplied by the reciprocal, 2/1, and you get, how you like them apples? Brooke, do you have a question? Well, what I wanted to do up here was, in order to use my formula, I need to figure out tangent of A. In order to figure out tangent of A, I took sine divided by cosine. So I did 1/2 divided by negative square root of 3/2. multiplied by the reciprocal, which is 2 over negative square root of 3. The 2's cancel, leaving you with negative 1 over the square root of 3. And then if you rationalize the denominator, you get negative square root of 3 over 3. So that's the tangent of A, not tangent of 2A, which is what I found here. Okay? Ben? Because I wanted you guys to see that. So all right. In this problem, we already found out sine of 2x and cosine of 2x, right? So if you've already found those two out, then yeah, go ahead and use this. But I wanted you to show you that there was another formula that you could use if you didn't already find sine and cosine. You know what I mean? Now, it might just be easier to always find sine and cosine. You might decide that. But let's say that they told us that the tangent of x was equal to square root of 3. Well, then you wouldn't do all that work, would you? You would just plug it right into there. So I just want to make sure you saw this formula. We didn't actually make use of it, but it is available to you. Does that help? All right. So those are double angles. Here's something that's of more value to you, and that would be half angle formulas. These are on this sheet right here. Half angle formulas are just like this. Okay? Half angle formulas are the green blue. There you go. I know, I'm not really concerned about the people in the video, but I know. Actually, I think that when people are watching the videos, they're probably watching the video on their computer and watching, say, Biggest Loser or something like that on TV at the same time. Or they're looking up videos on Facebook, or they are texting their friends. They're catching up on Twitter. They're stuffing their face with food. They're throwing things at their siblings. I don't believe that they're actually following close enough, so. Lindsay Stewart started it, okay? All right? Half angle formulas. Sine of a over 2 is equal to plus or minus square root of 1 minus cosine of a over 2. I know I should know these, but I don't. Cosine, it tells you how often you actually use these, so. Yeah, I know. Yep. All right, there's your half angle formulas. All right. It says find the exact value of the following using a half angle formula. Now, you guys, I'm giving you the basic problems here, okay? The basic ones. The basic ones. We're going to get to harder problems in a little bit. Not necessarily today, but it says find the exact value. I gave you the exact problem like this a couple days ago. Do you remember? Yeah, you were asked to find the cosine of 15, and you wrote it like this. Cosine of 60 minus 45. Do you remember that? Well, okay, so when you get to your test, if I say just find it, then you can use whichever formula you want. If I say find using a half angle formula, then you got to use the half angle formula. there are certain ones that you want to use a half angle formula on, as opposed to like the next one, you wouldn't use a sum or difference formula. So let's rewrite this as the cosine of 30 over 2. So again, you have to know where to go and when to grab which one. You got to recognize that 15 is half of 30. Okay? So now I'm going to put this into my formula. Good question. We'll do that in a second. How do you know whether or not it's plus or minus? Okay. So we got 1 plus the cosine of 30 over the square root of 2. Well, I'm sorry. over 2. That is what your formula says, right? Okay. Now, I want you guys to think about this for a second. If it's cosine of 15, which quadrant am I in? The first one. And if I divide an angle that's already in the first quadrant in half, which quadrant will I still be in? 1. So we are currently still in the first quadrant. Okay? We'll have a positive result. So now I need to evaluate this. I have the positive square root of 1 plus, what's the cosine of 30? Square root of 3 over 2 divided by 2. Kind of cool having a square root under square root, right? Yep. So what we can do now is let's combine the top into one fraction. Okay. So this would be what? Square root of 2 plus the square root of 3 all over 2 all over 2. Over 1. Multiply by the reciprocal. And what I will get is the square root of 2 plus the square root of 3 over 4. Yep. Can I take the square root of the top? Can I take the square root of the bottom? Yes. So I have the square root of 2 plus the square root of 3 all over 2. And that's the result. Yep, that's there's a whole study of mathematics about, kind of that complex square root piece where you have a square root under square root under square root. It's very useful later on in number theory. So we won't go there right now. So all right. Find the exact value of the following using a half angle formula. So now this is different. Let's Brooke, there you go. Let's convert it to radians. I'm sorry, to degrees. What is pi over 8 in degrees? Pi over 4 is 45 degrees, so pi over 8 would be 45 over 2, which is 22.5. Very good. So we will write it just like this. Whoop. Yep. So what we have here is if we convert pi over 8 to degrees, it's 22.5. We can rewrite that as 45 over 2. So that way we have a known angle. Again, we always want to make sure that we have a known angle. In this case, we do. Now, 22.5, could you have used a sum and difference formula to calculate that? No, you couldn't. You would have to rely on a half angle formula. So that's why it's important to know those as well. So we're going to utilize that now. We're going to say that this is equal to, again, which quadrant are we working in? First, so we'll be positive. So we have the square root of, is it 1 minus cosine? 1 minus the cosine of 45 degrees divided by 2. And now we go to work. What's the cosine of 45? Good. We should be able to write it as a whole fraction on top, so I would have a whole lot of 2's there, isn't there? So now I should multiply by 1/2, and I get the square root of 2 minus the square root of 2 over 4. Right? Does that look very similar to your previous problem? And a lot of these answers do tend to represent one another pretty closely. So, all right, let's look at the back side. Lowering powers. They hated this. This is really, really important, and we are going to look at this on Thursday. You get ready, because I am determined that all of you are going to get these questions right on the test. Okay? So, let me give you your short assignment. Okay, so you guys just notice that you don't have homework in this class again until Thursday, right? So I don't think that that's too unreasonable. Please give it a look. There's a lot more questions I want to put on that assignment that I don't have. So be ready for more. So.